Okay. So, we are looking at circumscription, and if you remember, the basic idea behind circumscription is that if you are given a knowledge base, let us call it phi, then we can do circumscription of that knowledge base with respect to certain predicates. And what we mean by this is that of all the models that we consider, which are models for this knowledge base. So, remember that a model for a knowledge base is a domain and an interpretation such that all the sentences in the knowledge base are true essentially. So, a model basically means that you choose some appropriate domain and interpretation, and you say that domain and the interpretation is a model for the knowledge base essentially. But in circumscription, we are interested only in minimal models essentially. So, in minimal models, extent of P or the interpretation of P is minimal. And in circumscription, we accept all those statements which are true in all minimal models essentially. So, we had seen some examples. So, we had seen a knowledge base, let us say this is our knowledge base. We said that so B stands for bird and T stands for Tweety. So, Tweety is a bird and chili is a bird, and chili is not equal to Tweety, and birds fly or normally birds fly or normal birds fly, which is the circumscription, which uses this notion of circumscription for all x, bird x and not abnormal x implies flies x. So, this is a knowledge base that was given to us, and we had one more statement which is not flies chili. So, we know that chili does not fly essentially. So, when we are considering the models are of interest. So, when we circumscribe this formula in default reasoning, we circumscribe phi or this knowledge base, which also we have called phi, with respect to the ab predicate. So, this ab stands for in some sense abnormal, and the general idea behind circumscription was that creatures which are not abnormal, or in other words creatures which are normal, they can fly essentially.
So, your for all statement should close at flies of x.
Yes. So, the basic idea is that if given this knowledge base that Tweety is a bird, chili is a bird, they are not the same, and birds fly in general or normal birds fly, and Tweety does not fly, we should be able to infer, our intention is to be able to say that yes, Tweety can fly, because normally birds are normal. This is a very circular statement, or you can say normally birds are not abnormal essentially, or most of the time birds are not abnormal essentially. So, things like that essentially. Now, we had seen that there are 4 models for this. In one model, both were abnormal. Then in 2 smaller models, only one of them was abnormal. So, here abnormal chili and here abnormal Tweety, and in the smallest model none of them was abnormal. So, I am only writing the abnormal statements, and we are using negation by failure, in the sense that if it is not mentioned that it is abnormal, then it is not abnormal essentially. Now, for this phi, we saw in the last class that that two of the models, two of these interpretations are models, which is this one, because this entails the knowledge base phi, and also this one, because this also entails the knowledge base phi. The other two are not models, because the knowledge base is not true in that. In the knowledge base we have already said that Pt is that chili cannot fly, which means chili must be abnormal essentially. And in the other models it is not mentioned that chili is not abnormal, that chili is abnormal. So, by inference chili is not abnormal, but that is not what we want essentially. Now, in both, now in this model, in the first model, flies Vt, because in this model Vt is abnormal, but this model entails flies Vt. So, there are two models, let us call them M1 and M2. And the definition of circumscription is that a statement we can infer that Vt flies if it is entailed in all the minimal models essentially. Now, there are two models here, one of them is minimal and the other one is not minimal, and since we can infer in M1, which is a minimal or smaller of the two models, that Vt can fly. Why can we infer that? Because in that model Vt is not abnormal, and the statements say that birds which are not abnormal, they can fly essentially. So, we can make that inference and conclude that Vt can fly, and it is enough to say that we can show this in M1. We do not need to show it in M2, because the definition given in Brackman and Levesque says that either you must be able to, either that interpretation should show that in that interpretation that the knowledge base should entail the sentence that you are interested in this case Vt flies, or there must be a smaller model. So, for M2 the second clause will apply, that there is a smaller model. So, we do not worry about that. For M1 we can show that. So, in this model by circumscription we can infer that Vt can fly essentially. So, we had seen this in the last class. Let me now modify the knowledge base a little bit and add a different sentence. So, instead of saying that chili cannot fly, let us add a sentence that one of them cannot fly. That either chili or Vt cannot fly. Now, what should we be able to infer in this with this knowledge base essentially? And we are looking at different forms of default reasoning. We had seen earlier closed world assumption. In closed world assumption, assuming that we are minimizing the abnormality predicate as before, you would, if you cannot show that it is abnormal, then you say that they are not abnormal. So, in closed world predicate you will say not abnormal Vt and not abnormal chili. Remember, this is how we did. So, both so in the closed world assumption both will be able to fly. If we choose the generalized closed world assumption, then we cannot add anything. So, none can fly. So, here both can fly. In the closed world assumption, we are able to add both the formulas, not abnormal chili and not abnormal Vt. So, both can fly. In the generalized closed world assumption, because remember there is a disjunction involved here, we cannot add either of them. So, generalized closed world assumption is more conservative and we cannot add either of them. So, we cannot conclude that any one of them flies essentially. What happens in circumscription? So, if you look at circumscription, which of these are models here? So, this last statement says that both are the lowest model. So, let me give them names M 0, M 1, M 2 and M 3. In M 0 none of them is abnormal, because nothing is mentioned there. So, this is not a model. But the other three are models essentially, because the only thing we have said is that one of them should not be able to fly. So, this for example, because we know that in M 2 for example, we know that V t is abnormal. So, we know that V t cannot fly. So, this entails this statement not flies V t or not flies V t. The sentence is true in this, because V t is abnormal, we know V t cannot fly, and because V t cannot fly, then one of them cannot fly. That is all we have said essentially. Likewise, in the model M 1, we know that Chile is abnormal. So, we know that Chile cannot fly, and because Chile cannot fly, again one of them cannot fly essentially. And in M 3, which is the largest model, both are abnormal, and so neither can fly essentially. So, all these three are models. But we are interested in what can we infer in minimal models essentially. So, which are the minimal models? M 1 and M 2 are minimal models. And anything we can infer in those minimal models, we will accept as a inference which is made by circumscription essentially. So, if you look at this knowledge base, the knowledge base says that at least one of them cannot fly. So, not flies Chile or not flies V t essentially. The closed wall assumption adds both are not abnormal, and in fact, this is inconsistent, right. Because one can infer flies V t and flies Chile, because they are both are not abnormal essentially, and but we have said that one of them at least cannot fly. So, the closed wall assumption is inconsistent. In the generalized closed wall assumption, we cannot infer anything essentially. But if you look at this statement, so let me write it like this. Let me go back to using blue. If you look at this statement and the app predicate as before. Now, this entails flies V t or flies Chile. Why is that? So, let us consider the minimal models one by one. There are two minimal models we have said. In M 1, Chile is abnormal, V t is not abnormal. This means it can fly. It means one of them can fly. In M 2 likewise, we know that Chile is not abnormal. From this we can infer flies Chile, and from this we can infer flies V t or flies Chile. So, in both the minimal models we can show that one of the two birds flies, which is less cautious than generalized closed world assumption. In the generalized closed world assumption, we could not infer anything about the two birds. In circumscription, we can say that we know that one of them can fly. Now, of course, when I say we know that one of them flies, you of course have to take it with a pinch of salt, in the sense that in the world in which the number of abnormal creatures are minimal, in that world or in that model, you can say one of them will fly. And in the minimal model, only one of the two birds needs to be abnormal essentially, and that would be a model, because that would, the knowledge base that we have would be satisfied in that. And in one model Tweety can fly, in the other model Chili can fly. So, in both models one of them can fly essentially. So, that is a, in some sense, more fine grained nature of circumscription as composed as compared to the closed world reasoning essentially. What is more, we can handle existential quantifiers, or we can handle unnamed individuals supposing we say we add the following sentence: there exists X bird X and we also say and X not equal to Tweety and X not equal to Chili. Supposing we add this to phi, then in circumscription we can infer that this unnamed bird can fly essentially. And yeah, if there is a bird which is neither Chili nor Tweety, but we have not named that bird, and we can still infer that this unnamed bird can fly. This is again something that we ran into problems when we are looking at generalized closed world assumption essentially. So, let us say when we add this we get phi prime, and now if we add the following to the following sentence, which is not flies X. So, it is part of that essentially, that there exists X bird X and not flies X and X not equal to Tweety and X not equal to Chili to phi. So, this is a different, we have added one more fact essentially. Here we can see that we can infer that there exists an X such that for all Y bird Y and flies, sorry, not, I should use be consistent. So, bird Y and not flies Y is equivalent to saying that Y is equal to Chili or Y is equal to X. So, what have we done? So, once we have added this extra statement that this unnamed bird cannot fly, then we can say that if there is a bird which cannot fly, it must be either Chili or it must be that unnamed bird essentially. Okay, so let us look at some difficulties. So, as I said, this area of default reasoning or reasoning under uncertainty is still very much an open problem, and we still do not have absolutely satisfactory solutions, but people have been working on these sort of things essentially. So, let us have a different model base, different knowledge base, in which some of the older things are similar. For all x, bird x and bird p t, and we have another statement that for all x, penguin x implies bird x and not flies x. There is a slightly different knowledge base, in which there is only one bird, which is Tweety, and of course, we have the statement that birds fly, which we use in all the knowledge bases that we have. But we have another statement, it says that penguins are birds who cannot fly essentially. So, if x is a penguin, then x is a bird and x cannot fly essentially. Now, does Tweety fly in this knowledge base or not is the question essentially. Now, you can see that in a minimal models, there are no abnormal birds. We can write this as saying that phi entails that there does not exist x such that why this is because this is what circumscription says, that just minimize this set of abnormal people essentially. So, in the minimal model there are no abnormal birds essentially, but what is the problem with that? The problem with that is that in the minimal model there are no penguins. So, circumscription has forced us to minimizing the model of, and in a sense minimizing the number of abnormal birds, and we do not know of any bird to be abnormal. So, in a minimal model no birds are abnormal, but we also have a statement that penguins are birds which cannot fly, which implies that penguins are birds which are abnormal, and we are saying that there are no abnormal birds. So, this means that there are no penguins essentially. Now, that of course, is too harsh a conclusion to come to essentially. So, people have tried to get around this problem by saying that you have two kinds of predicates. So, one attempt has been that there are two kinds of predicates. One is fixed. By fixed we mean their extent is fixed, that we cannot modify them essentially. So, which includes penguins, which also includes bird essentially, and the other is variable whose extent can change, and that includes things like flies. So, if we do this, then we can infer that we can infer with this phi, same phi, that for all x, bird x and not flies x equal to penguin x. So, if we keep the set of penguins fixed, so we have said we have these fixed sets, penguins, birds, we cannot change, we cannot suddenly say something is a bird and something is not a bird. No, or we cannot say that something is a penguin and at some point say something is not a penguin. And when I say some point, it means with additional information essentially. But the predicate like flies is a variable set, that if we only know that x is a bird, then we can say that x can fly. But if we also know that x is a penguin, then we can change that and say that x cannot fly essentially. So, it is a variable predicate. The set of individuals which can fly varies with the amount of knowledge that you have essentially. So, we have this notion of fixed and variable predicates. Okay, so, we said in the fixed we have penguins and birds, and variable we had flies or bird or f, whichever notation I am using essentially. So, this does not really solve all our problems, because in some sense now the knowledge base entails this statement that for all x, if you are not a penguin, then you can fly. This is true in our knowledge base, that birds which are not penguins can fly. So, if we knew, for example, so if we knew that Tweety is a canary, and we knew that that canaries can fly, and we know that canaries are not penguins and that kind of stuff. So, for all x, canary x is not equivalent to not penguin x, then we should be able to conclude that Tweety can fly essentially, because we know that Tweety is not a penguin essentially. But the big question is, what if Tweety were a penguin? So, in our original knowledge base, in which we have only said that Tweety is a bird and we have not said anything about this thing. How do we know that Tweety is a penguin or not a penguin essentially? So, how can we say that Tweety can fly or not fly essentially? So, that is a problem. We need a solution for that. So, one suggested solution is most birds are not penguins. Remember that our whole this exercise of default reasoning has started off by saying that if we say that some x is a bird, Tweety is a bird, it is normal for us to be able to infer that Tweety can fly essentially. And so, that is why we started with circumscription and then we said that circumscription creates a problem because it does not allow the existence of penguins itself. And we said that okay, we will allow penguins, but we will keep them as fixed birds essentially, which means the set of penguins cannot change essentially. But now we do not know whether this treaty belongs to this set or it does not belong to this set. So, we are trying to add another piece of knowledge that there are hundreds of species or thousands of species of bird. So, most birds are not penguins essentially. How would we say that? We would say that by saying for all x bird x and not. So, I will use p here, they are not abnormal with respect to being penguins, implies not penguin x. So, I am just trying to express the fact that most birds are not penguins.
The abnormal predicate, is it a predicate or does it have X? Abnormal
X. I keep making this mistakes. It has a argument x. So, if x is a bird and x is not abnormal. So, this is a different kind of abnormality. The first abnormality we saw was with respect to flight, and there we said that ab means you cannot fly. Here we say that ab means you are a penguin essentially, or you. So, most birds are not penguins. We are saying that if x is a bird and x is not abnormal with respect to being penguin, then x is not a penguin essentially. But the problem is a fixed predicate. So, we have run into a problem here. First we started off by saying that the set of penguins must be fixed, and we cannot say, and now see in this sort of an inference, when this inference is analogous to saying that most birds can fly. Here we are saying most birds are not penguins, which means we started off by putting penguins in the set of fixed birds, but now we want it to be in the set of flex the variable set essentially, because we do not know who is a penguin and who is not a penguin. So, we will keep it as a variable set. So, you can see that this kind of problems abound in reasoning with circumscription, and if some of you are interested in doing research, then maybe default reasoning is going to be a good area, because we still need to do a lot of work in that essentially. We need to still look at a couple of more models of default reasoning, which I will do a little bit later, but in the next class I want to take up an application that we had visited earlier and see how circumscription is used in that application to reason in a situation where you have incomplete information essentially. So, we will do that in the next class. We will stop here.